I'm Maggie Stark. I'm going to be presenting today on orchestrating data quality, quality data brought to you by Airflow. So I'm a data engineer at Astronomer, and by now you've probably heard a little bit about Astronomer, but we're working to drive the Airflow project forward, not only by contributing to the OSS code directly, but also through educational resources like docs and certifications. We also have our own product, Astro, which helps you host and manage your Airflow infrastructure. And then we're also working to build other features that will make it easier to build and observe your Airflow pipelines. That's enough about Astronomer. So inside of Astronomer, I'm on a small but mighty data team. We're a team of 4 that are supporting roughly 25,000 tasks a day, and that is across all domains of the data: product data, marketing data, sales data, finance data, you name it, we're involved. And so we build critical Airflow pipelines, both operational and analytical. So we have billing DAGs, and we're delivering data to internal dashboards, but also to dashboards inside of our product Astro. We're feeding data to customer bots. And because we're such heavy users internally of Airflow and also of our own product Astro, we are sort of in this unique position inside of the company where we get to be involved in a feedback loop. So we get to see features as they're getting developed and test them early and give that data user perspective, and ultimately hope that it's a better feature in the end. And sometimes even the work that we're doing on my team is seen by product and then used and to build a feature. So in some sense, we're data influencers inside of the company, or product influencers inside of the company. But today I'm going to talk about why my team decided to sort of focus on data quality and as a product, take a step back. Because we're a small team that's supporting a lot of data, data quality is important, and we wanted to be more proactive about it and less reactive because we don't have the manpower for it. And to talk about that, I'm going to take us back a little bit and tell you about how we develop our Airflow environment, just to give a little context, because that's ultimately plays a role in how we decided to solution data quality. So in data work, there's a lot of repeatable processes. The data you work with day to day might be different, but what I'm doing with the data is usually the same. I'm ingesting it, or I'm trying to move it from A to B, or I'm delivering it somewhere, or transforming it, creating a table, incrementing a table. And what we've done with all of these processes is we've packaged them up into reusable task groups, custom task groups. I think it's pretty common in Airflow to talk about custom operators, and custom task groups are just a play on that, just to level up. And so we've taken all of these processes and made custom operator or task groups for all of them, and that just ensures everyone on the team is following the exact same steps for ingesting data, transforming data, etc. So no one is really building a ETL pipeline from scratch anymore. They're all using the same task group. So I'm going to show now an example of what creating a table in our environment would look like. It's going to look a little different because I should also mention we're using a declarative wrapper on our code. The declarative wrapper is open source, so nothing I'm going to talk about today is really gated. So we're using Gusty. There's other ones like DAG Factory that are also open source. But what this does, this declarative wrapper essentially turns our code, makes our configuration code, and turns this SQL file into an Airflow DAG in the end. And so you get a little bit of YAML front matter, and then at the end you have the ultimate purpose of your file, the code you want to run. And so in this case, we're going to create a table. So in that YAML front matter, you typically call in your operator or your task group, and then you feed the relevant parameters. And so in this create table task group, I'm calling in that first line. I'm then going to pass in the table definition, the field descriptions, where this is ultimately going to land in my data warehouse, what schema it's in, the primary keys for the table, which also gets turned into a uniqueness test and a null test, and then any other data integrity tests, other uniqueness checks you want to do, or null checks you want to do. And then I'm finally going to write my relevant SQL. And so this is great because it I wrote no Airflow, and I was just able to focus on the context of the problem I'm working on. And so on this next slide, that file gets turned into this task group in the Airflow UI. And so we have a create table, temp table, and then we test the temp table, those uniqueness and null checks that I specified on the last slide. Once those pass, hopefully, then I will swap that into production. I'll add my table documentation. And so that table documentation is also great because it powers our data catalog. So our other users internally can explore and see what's available. And then I'll drop the temp table and I'm all done. I have a calendar table in my data warehouse now. And so I wrote one file and it got turned into n tasks. And so this has been a really powerful framework for my team, and it's allowed us to stand up a lot of data in our warehouse and service a lot of data to our company. We were sort of hitting this issue of users were looking at our dashboards and finding issues in the dashboards and then reporting into us more often than we were finding them. And so that's not the best look for data or user trust. So I'll give an example of that. A user was looking at a dashboard, and this is a graph of and they noticed a big drop. And after we investigated, we realized that that drop is because the tool that we were using to track our web traffic had changed its output. And so it was kind of an arbitrary drop. In the end, we switched which tool we were using for web traffic and went back to normal. But this brought up a question of, well, how can we be looking for these issues in advance and alerting us so that our users don't have to alert us? We should be checking for regressions in data sources, regressions caused by our code deploys, regressions just from business processes changing. Data's not static. Our testing needs to be continuous. And go beyond just our sort of code validation where we were doing our uniqueness checks and null checks. And so we were like, well, we'll just run a bunch of tests in our data warehouse looking for issues. And so we don't focus too much on the image. It's just a subset of this standalone DAG, but we decided to create a standalone data quality DAG, and that image is just a subset of it. It was very large because it was doing all of our covering all of our data warehouse. So it was kind of hard to maintain. It was ultimately duplicative because we were kind of managing dependencies that we have in other parts of our code base and this other DAG as well. And then we had poor visibility of what we were actually testing and how much we were testing. And because this was a standalone DAG and not in the developer's usual context, it wasn't well adopted. And so we figured, well, in order to get better adoption and more testing in our data warehouse, we really need to embed testing into our day-to-day work and not have it be this easily forgotten step. And so up until now, I've talked about that task groups are our main focus and that we try to make everything as standardized as possible. And we decided, well, we could do that with testing as well. So we created a test task group, and then all of our existing task groups, we could just make a call to that test task group. And now all the DAGs that already existed have the ability to add testing to them with no effort. So if we revisit this file I showed before, we now have this new section called validations, and this is just sending the parameters to that test task group. And so as new issues come up, we just have to add another line of configuration just to add another test. One thing we did do here is we expanded on what kind of tests you could run. We had to go beyond just checking for nulls and uniqueness. We also needed to be able to test custom conditions, aggregations, partitions, and so the limit of what you can test is kind of gone. There hasn't been something I wanted to test that I couldn't with this yet. So what this did, and this also, because it's in this file, makes it a lot more apparent what is being tested, how much is being tested, what isn't being tested if this is missing. And so what this does is just adds another task into our task group. And if you expand that, we're not doing anything fancy. It's actually just creating SQL check operators, which are native Airflow testing operators. There's a lot of powerful testing you can do with just Airflow. So those tests get turned into SQL check operators. And I mentioned that we had testing before, and primarily null checks and uniqueness checks. And so we updated that original test task to now reference this task group. And so now we have all different types of testing in our environment. We have data contracts where we're primarily testing our ingestions or data we're consuming from broader parts of our data mesh, and just checking that the data matches our assumptions, its shape, the values. We still have our data integrity tests where we're checking primary keys and nulls. We also have data accuracy tests where we're making sure that our metrics are consistent, that my daily gain is going to sum up to my monthly gain, that the customer count that I'm presenting to finance is consistent with what I'm presenting in MarkCust to my sales team. And then we also have these non-blocking validations where we're checking maybe some more business processy sort of things, like is the contract date filled in on a Salesforce opportunity? And so this is just a visual representation of the layers of our data warehouse and how we're set up and where these different types of tests exist. And so in our ingestion and model layer, we have more data contract type tests. And then beyond that, in modeling, we're more focused on data integrity, accuracy, and the non-blocking validations. And so this is great. We've got a lot more testing going on in our warehouse. We like that. But we sort of noticed that we're getting more noise in Airflow. Because each of these SQL check operators can run more than just one test, when it goes red, I have to click in, see what actually failed, which test failed, which is cumbersome. But then also sometimes the test that failed is not something I can really fix as a data engineer. Maybe a contract date is missing and I need to go get sales ops to go update Salesforce, which is fine, but again, kind of cumbersome. But then the next time this DAG runs and it fails, I have to go back into the logs again and say, is it the same failure? Am I still waiting on that update? Or is there a new test that's failing that I need to look at? So we decided to go back to our testing task group and add an additional layer of specifying whose fault it is. Internal, external. Internal meant the data team it's probably something we should be able to fix, and external, it's someone else's problem to address. And then to avoid going into the Airflow logs, we also started logging this data to our data warehouse. So that's the only customization we've sort of done here on the native operators, is we added logging to our data warehouse of the tests. And that logging looks like this. And so the logging tells us the DAG, what run, what table was being tested, what was the test, how many rows failed, who's the owner of it. I mean, it logs if it's success too, but, and then it also stores failed rows. And what we do with this is we have, for our data owners, dashboards, and these show their data quality issues on their dashboards, and they get alerts when their dashboards have data in them for them to fix. So we're able to focus on our internal issues, and they're able to see all the data that they also need to be responsible for fixing. So this moved us to a more shared responsibility approach to data quality as well. And now that we've logged all this data, we're starting to think about how do we quantify it and measure the quality of our team, I guess. How is our data quality overall? Are we improving? How quickly is it taking to resolve things? That sort of thing. So that's what we're working on now. So just to recap, we use Airflow native operators to perform all of our checks. We have a write, audit, publish, audit again approach to our data warehouse. Our checks are configured inside of the task definition. I mentioned we had a standalone data quality pipeline. That's gone. We have sort of new different ones, and those are just for doing tests against things that aren't really tied to one operation. You're comparing two tables versus testing one table. And then we surface the validation results in dashboards so that other people can take action and take some of the onus off the data team for resolving everything.